three-phase transformer. That is usually used to generate so so in the power transmissions, there was a step up, step down transformer in substation. So they have the four case: Y, delta, delta Y, delta to delta, and Y to Y. But usually they're gonna using for Y to delta, step down, and delta to step up. That should be the screen here. Oops, it's right there. So to summarize, we learned before, this is the delta, this is the Y connection, okay? So that was over here, like 30 degree. This is so this one in the delta connections, line voltage, the other things. Yeah. Okay. Line voltage, same as phase voltage, or sometimes the winding voltage. But that's, however, line current is the equal to √3 times winding current or phase current, okay? And minus 3 degree phase shift. For the Y connections, it's the delta. So the Y connection is different. Winding current means like phase current is the equal to line current here. Okay. However, line voltage is equal to √3 times the winding or phase voltage. So Y minus 3, minus 30 and 30 and √3, we have already made a derivation in previous chapter. You can see that in my lecture printout. Okay. All right. So we're gonna really simple questions. So delta. This is the winding inductor. Okay. Okay. This is A, B, C. This is my delta connection. Okay. And that was this is the answer 1 and answer 2. C, B, A. It's the Y connection. So usually this is the source. Okay. So the power in and the power out. So usually that part is the rod part. This is source part. This is the transformer. Okay. So the question is, let's say this now. The primary winding voltage 480 volt. Secondary winding voltage that was 13. Okay. And then power transformer 14.8 kVA. Okay. So that was the given here. So now, okay, so let's see. What is the turns ratio? We learned before n sub 1 and n sub 2. So 1 over 3 sub 2, I sub 2 over I sub 1. Okay. So we are looking for is turns ratio. Okay. So from the questions, we have the clue, primary winding, base voltage, secondary winding, and so 1 over n sub 2. So the turns ratio is 4 over 1. Okay. This is the turns ratio. Now, what is the line voltage of the delta? What is the line voltage? The delta connections. So go back to the questions. So primary side is the delta. They have a hint for the primary winding voltage. Primary winding voltage means primary phase voltage. This is 480 volt. Means in the delta, we learned before, line voltage, phase voltage should be the same. So V sub L, 480 volt. That is the answer. Now, oops. Okay, what is the line current? What's the line current? Good. The delta connection. So that was from the go back to here. So apparent power capacity of the rate transformer is 14.4 kVA. So 14.4 kVA is 400 VA apparent power. So the three pace was 3 times spell times spell. That was I spell. So here that was for 0 3 times 50 times 80 was that was from here. Finally, after calculations, that was 17.3 amp. Okay, for delta. Okay, that was the answer. So for what is for line voltage of Y connection? Okay, so that is go back to upstairs here. So Y connection, that was formula is line voltage is equal to root 3 times phase winding voltage root 3. So line voltage here. Okay. So secondary side, the winding voltage, this is secondary, just primary. Okay. Secondary side from the given, that was 120 volt. So right there, okay. So right there, what is the phase voltage of delta connection? Phase, goes the phase current, root 3 in I sub L. This is just the amplitude. And for delta. And 6. What is for line current of Y connection? Now, the delta and delta connections. So this is the primary, usually the generator source part. This is the secondary, it's the load part. We assume this is 138 kV. This is 4.16 kV. Okay. Now, the power plant draws 86%. Okay. This is the load part. So now, question one. So here, S is what? Cosine theta over P. That was 21 watts, 0. Oops, not that watt, 0.86, because this is the power factor right there. Okay. 24.4 millivolts. Okay. What is for current in each high voltage line? That's current. That was line voltage, three phase. Isabel S. S is 4 megawatt, 6 into 6. And so 3 times line voltage. Just a line, just a line. Yep. That is current in each low voltage line. Okay, low voltage. Here, secondary side. So right there, here, second, this is 1. Go to 3 times Isabel, secondary prime, as 24.4 10 to 6, 3 times 41610 3386. Okay. And question 4, what is the current in the low voltage lines? You know, the current in low voltage line means that was line current, the secondary part. Okay. So maybe in the delta, that was, um, you know, learned before, line current with the 3 times. So Oh, I'm sorry. This is the winding. Okay, low voltage is the winding. This is the winding. It's low to 3. Iso 2. That was right there for KM 31955 AM. This is 2 KM. Okay. All right. That's it.